Hello everyone. So today we're going to discuss another data structure, which we call HashTable, or commonly known as HashMap. We're discussing data structures with the goal to build up our concepts for solving problems, especially interview problems. And with that respect, HashTable is one of the most important data structures. So this is a suggestion for not for you. This is a suggestion for all, that whenever you are solving a problem, an interview problem, or any other kind of problem, always keep HashMap on top of your mind, because HashMap is so much useful to design efficient algorithms. And we will talk like why HashMap is such an amazing piece of tool and such an amazing data structure. So just to give you some concepts, using a hash map, you can insert your data in order of one time. And the best thing there is you can actually search your data also in order of one time. Like, that is an amazing thing. Uh, Order of one means you can actually do it in constant time. So that looks like too good to be true, but let's discuss and see how actually we achieve that. Okay, so uh, okay, so let's first see what kind of data we store in a hash table or hash map. So probably it looks like some kind of map. So this is the type of data that are actually most appropriate to store in a hash table. Suppose we have list of the countries. Brazil. Okay, let's write it here. USA, UK. Okay. So each of these countries, so say key value pairs. So key is the country and the value is, say, and the population. So population is like 150 million, something like that. USA is Washington, D.C. Population like 330 million. UK, 70, something like that. Okay. So basically, this is the example of key value pairs. And so every key is mapped to a value. And this is one of the best things that can be stored in a hash map. So usually in a hash map, we put the data in some kind of arrays. So that means, suppose for Brazil, we want to put it, say, we want to put Brazil's data here, say here, okay? And then say we want to put US's data here. Then UK's data we want to put here, okay? Somehow we have to know that whenever we are inserting Brazil's data, it goes into position index 0. US's data goes into index 2, right? UK's data goes into index 3 of this array, right? And inside it, we have this data like Brasilia 150, something like that, okay? Similarly, US's data goes in here, UK's data goes in here. Now the question is, okay, next time if someone says, okay, search Brazil, the hash map or hash function should have the ability to directly look up and know that, okay, I have to go to index 0 and then return Brazil's data. Now, obviously, the question you have is how do we know the mapping? Like, how do we know that Brazil's data goes into look like index 0, US's data goes into index 2? So there, the trick is something called hash function. So let's talk about hash function. So that is the trick. So a hash function is something that takes the key. So it's some kind of, say, hash function. It takes the key and converts it into an index. That means, suppose we have some kind of hash function that takes Brazil and converts it into 0. Okay, so when we insert Brazil, then what it does is it first does a hash function of Brazil, applies hash function on Brazil, and then it knows, okay, this is 0, so it says, okay. Internally, what it does is inserts into location, say, my array is something like this, A0, okay? So internally, it actually does this. Similarly, if I say like search Brazil, it again does this hash function, applies this hash function on Brazil, and then it searches, internally it searches location 0. So it can directly go to location 0. Now, what is that hash function that actually does this? Let's try to define an simple hash function. Say, so this was my array, right? So we want to create a hash function for Brazil, USA, and UK. Okay, so let's do that. Sorry. Okay, so we are familiar. So hash function, there is no specific rule that how the hash function may look like. We're just trying to create our own hash function. That's it. Okay, so let's see this. This is the ASCII code, for the characters. So B is like 98. So B is 98. R is uh, R is, you see, 114. A is again 97. A is 97, right? We're taking the small cases. Z or Z is 122. And I is 105. I is 105, right? This is the ASCII code. And L is 108. Okay. U is 117. And K is 107. And for USA, we need also S. S is 115. Okay. So we got our ASCII codes. So basically what I'm trying to do is I want to I want to define a hash function, which is the sum of ASCII codes divided by or mod by, not divided, sum of ASCII codes mod of 5. Okay, so this is my hash function. This is a very naive hash function I'm defining. So let's try to define it for Brazil. So Brazil is 98 plus 114 plus 97 plus 122 plus 105 plus 108. Okay, so let's do this. 8 and 5, 13, and 22. 13 and 22 is 35, and 14, 51, and minus 2, minus 5. 51 minus is 46. So this mod 5. So 46 mod 5 equals to, how much is it? Is 1, right? So this is 1. Let's do it for US. For USA, it's 117 plus 115 plus A is 97. So it's 15 and 17, 32, 32 minus 3. It's 32 minus 3, 29. So 29 mod 5. Because 29 mod 5 is, how much is it? It's 4, right? And for UK, is 117, U is 117, and K is 107 mod 5. That is 24 mod 5. Or let's say another, let's take another country, UAE. Say UAE. I am just changing it to UAE just to make it easier to understand. So UAE is 117, A is 97, and E is 101. So it's 8 minus 3, 5. 5, so it would be 15. Okay, so I have omitted the hundreds here. So it is a 500 and something. This is also 520, and this is, sorry, 320, and this is 315. So 15 modulo 5 is 0. Okay, so that means Brazil's data goes into index 1. US's data goes into index 4, and UAE's data goes into index 0. Okay, so this is the simple hash function that we defined. That is sum of the ASCII characters modulo 5. Okay, so next time, the same way, if someone searches for Brazil using the hash function, we can calculate 1 again, and just we go directly to location 1, like array location 1, and find the data, right? So from this one, you understand how we can insert our data in constant time. Insert becomes order of 1, and search also becomes order of 1 or constant, right? Because you know the hash function, your program knows the hash function. It just calculates it and puts the data in an array internally, and this makes the whole thing so easy. Now, here are some things. Obviously, you are already asking questions. So suppose you say, probably my hash map that I defined is not big enough. So it may have, say you have 100 million key value pairs, right? 100 million key value pairs. So two things. First thing is, do I have an array of size 100 million? And second, can my hash function for each of these records, right? So each of these records are like key value. So each of these records for each of these key value pairs, create separate index. And my hash function creates separate index for each key value. Okay, obviously that's a very good question. The reason for that is, let's look at this one. When you say it like, okay, the next one. When you said like, suppose UK, right? UK was 117 plus 107. That is 224 modulo 5. So 24 modulo 5 is 4, right? So if I had put UK, UK's data also had gone here. So it's of is if you have a like hash function, in that case, it's very much possible that two of the keys will be mapped or multiple of the keys will be mapped to the same index. So can my hash function create separate index for each key value? The answer is no. It may like create collision situation, as you say, like USA and UK for the hash function that I defined. USA and UK both actually go to the same location, right? So for that, what you have to make sure that no, it's not guaranteed. So you have to have a very good hash function. Okay, so a very good hash functions means that if you have like 5 set of data, say Brazil, USA, UK, UAE, and then Bangladesh, okay, the hash function should be good enough that it uh, maps them to different places so that they don't collide, okay? So this is an example. Suppose we have a hash function, and this one actually maps each of the keys to different indices. So that is what a good function, hash function is known as. So the hash function needs to be good. The second thing is, obviously your data always may be like bigger than the size of the hash map. Suppose you have 100 million data, right? So we go back to the first question. Do I have an array of 100 million? Obviously not. Maybe my array size is 1 million. Okay, so say my array size is 1 million, but I have to put 100 million data in it. So how do I do that? So even with a very good hash function, each of these locations will have like 100 data in it, right? So what we do is we create, this solution is called as chaining. There are different ways to, so obviously there are going to be collisions. So if the array size is 1 million and your data size is 100 million, then even a good hash function maps 100 data here. There'll be 100 data here, 100 here, right? So that means there is a collision. How do we solve it? So one solution is called chaining. So chaining means you actually will have a linked list. So this will be a linked list. Okay. Or let's draw it like this. So this is index 0. So index 0 is actually, so next, say Brazil, your hash function maps Brazil to here. And then next, another country, India, also is mapped to the same location. In that case, what you do is you put the information for Brazil here. Next time when a new data comes, you just put another node and put it here. Okay, you put it here, and then you put it here. Similarly, you just do it here. Okay, so this is called chaining. This is a collision avoidance mechanism. And in that case, obviously, insert and search is no longer order of one, because once you're inserting something, uh, if your hash function is super bad, a very bad hash, what is a very bad hash function? A very bad hash function is a hash function that actually maps everything through the same location, everything, right? In that case, what's going to happen is if you have n amount of data, then what's going to happen is your insertion is also going to take order of n. So this is a very bad hash function. Okay, uh, because in linked list I cannot just jump. Every time a data comes, I have to start from here and then go all the way to insert to the end, right? Okay, and then search also becomes order of n. Suppose someone says like search India, then you have to actually come here and then go through to see what is the India's data. Okay, but there is a good thing, like what I was just talking is the implementation details for a what I say, like implementation details of a hash map or hash map. But in the programming, we will be using different programming languages, and programming languages are actually smart enough to handle all of these, defining good hash functions and avoiding collision. So for the problem solving purposes, we will consider that insert is order of one and search is also order of one. For example, if I show you, so you don't need to worry, like just I gave you the theory that in practice, for not so good hash functions, search can be order of n, but uh, practically or for the program, the languages that you are going to use to solve problems, those hash functions are actually very nicely defined. So we can say on average, they're actually constant time operations. They do constant time operations. So let's look at the hash map for Java. So in Java, the class is called HashMap. And some of the key methods of are one is contains key. So it returns, given any key, it returns whether that key is in that hash map or not. And then obviously get is like the search. So you give the key, it will return the value to you. So get, and then you can also, another method is put. So this is the two primary methods, put and get. So for put, you put key and value, and for get, you just give the key, it will return the value. And then to remove something, remove is the function. So remove. So remove, uh, put, get, and there are some other functions, say key set. Key set will return all the keys to you. Okay, so those are the main functions that are like contains key, key set, uh, put, get, and remove. Okay, so this is the hash map that is defined in Java. It's But for other languages, just uh, take a look at what is the hash table or hash map implementation in your uh, particular language that you want use. So that's it. We talked a lot about hash map, but I tried to provide or explain how HashMap works, how data is stored, how hash function is used to deduce indices. And finally, what I told everyone is you don't need to worry about all this stuff since we are using built-in HashMap or HashTable capabilities in programming languages for the problem-solving purposes. We can assume that the search and the insertion and the search both can be done in constant time, and which is a very powerful thing. Okay. One last thing, you may ask like how it's possible that HashMap is actually doing these insertion and search things so fast. Well, there is a trade-off. The trade-off is you are using a lot of memory, extra memory for that. So uh, suppose when you are actually declaring a hash map, what you are doing is, so when you are declaring a hash map, uh, essentially what you are doing is you are defining an array, right? A big array beforehand. So maybe you only have, say, a few data to insert into the hash map. Say you have 10 data, but once you are actually defining it, you are creating a hash map much bigger than that probably. And because of that, some of the spaces like here, you see this is empty, this is still empty, this is empty. So you're using some extra space. So it's not like very efficient use of space, but at the trading of this inefficiency, we're actually getting efficiency in searching and inserting. Okay, so that's it. And the last summary, just remember this: order of one, constant time, insertion, and search. Thank you everyone for listening to this. We'll come back with another discussion.